these roughing inspections. The same in the commercial, except that residential doesn't have requirements from electrical roughing inspection. It also allows a building official to designate an agent, like a third-party inspector. I don't know of a jurisdiction that owns the equipment and does the duct blaster and the door blower tests. Because any contractor that has one fail, then they're going to challenge the calibration of the machine and the skill of the inspector. Generally, inspectors don't do tests, they observe tests. So having a third-party energy inspector, that's key, especially for a jurisdiction that smaller or they don't have the resources to have an expert on site. Jurisdictions that I've advised, as they've adopted the 2012 Energy Code, have a very good third-party inspector registration so that there's no conflict of interest. The inspector can't get 10% of their work off any one that they're testing for. And they're involved in plan review all the way to that final energy certificate. Don't accept run rate or, com check or res check from the builder. It all has to come from that third party. But it depends on the jurisdiction, and the code is more specific than allowing the building official to do that. Existing buildings is something new. It's been in the administrative section, chapter 1. Now it has its own chapter, chapter 5. So that you have one point to go for alterations, repairs, additions, and also that's an avenue for more requirements for existing buildings. Most jurisdictions have also, when they adopt the codes, they adopt the IPMC, Property Maintenance Code. So no matter how old a building is, it still has to meet those codes for continued occupancy. So we may see some of those elements. For existing buildings, as we said, this is a whole new chapter. A change in occupancy almost always requires all the energy codes to be met. There's a new definition for historic buildings in the energy code. In fact, if you check the errata, which are corrections after printing, accounted 22 in the energy code. So you can go to iccsafe.org and look up errata, because one of the big changes in the first printing that I've got, the whole definition of historic is thrown out. So as it goes through all the code process, especially when it refers to other code sections, it might have to, so that's important to check. Usually, the parts of the building that are not modified are allowed as is. If they're working properly, they were permitted at the time, and they met the code requirements. These are the sections: additions, alterations, repairs. They're all addressed in that chapter 5. If people want to change their garage into a den or a bedroom, the requirements are in chapter 5. Also, here you can see exceptions to each of those. If you're going to put storm windows over your existing windows, that doesn't require a permit or energy code. It's actually trying to get closer to it. Repairs or alterations, one of the big things we're going to see is with water heaters. You know how the NADCA requirements for water heat efficiencies went into effect April 16th of last year. So now anything over 60 gallons, it's going to be so energy efficient. The requirements, they're bigger, they're more expensive. Most home builders that I've seen, instead of putting in an 80-gallon water heater, putting in 255s. But they're wider and they're taller, and they may not fit in the enclosure. So they might want to just go to, instead of a tank water heater, they might want to go to a gas or electric tankless water heater. That is going to require a permit and has to meet the energy code, especially for load calculations. The electrical code requires that bathrooms only be served on a separate circuit. You can serve 2 bathrooms on one circuit, but you can't serve anywhere else in the building. If you put a tankless water heater in each of those, it can easily overload that circuit. If you put a gas line in there, then the gas line, the load calculations have to be done. You have a cook stove, a dryer, an oven, a furnace, all gas, and then you put in a couple of gas tankless water heaters. You can be 500,000 to 600,000 BTU max when they're all running. Most residential gas meters are set for 400,000 liters a year. So the utility would have to change out the meter. So that's why there's only certain exceptions for this to protect people from themselves. The contractors who aren't as skilled. One of those in there, the exceptions, the bottom one, glass-only replacements. If a piece of glass is cracked or broken, you can replace that. But if you replace the sash with it or the whole frame, it has to meet the new energy code requirements, and most jurisdictions require it. So from now until break, which, what time are we taking break?
10:15,
Okay.
45 minutes.
Okay, for the next 45 minutes, we're going to discuss the mandatory requirements. Because every path that we take from this point on, they all have to meet the mandatory requirements. But then, after that, it goes into others. So they meet the mandatory requirements, and then you have a prescriptive option. And under the prescriptive option, there's 3 different ways to comply with the building thermal envelope. You have a performance option, which is a comparison, the new energy rating index, and then alternative compliance codes. All of those first have to meet the mandatory requirements. So that's what we're going to discuss first. So first, the certificate has changed from the 09. It was different to the 12 to the 15. More data is required every year. Now the certificate, it doesn't have to be posted on the electrical panel. Sometimes there's a conflict. We don't want to cover up the panel schedule, the circuit designations, or any of the identifiers that panel needs code. It can be on a furnace wall, utility room, or another location. It should be in a location where repairs will not remove it or damage it. The purpose is so that the homeowner can compare any replacements that they have to buy later to what is already there, so they can at least get better or the same. Also, the duct testing and air leakage tests, they have to be shown how the test was conducted and what the results are. And any of these unvented room heater, electric furnace, baseboard heater, they have to be listed on that certificate, but no efficiency can be listed for that. Then the building thermal envelope. This is the big thing. Purpose of the building thermal envelope is to control changes in airflow, moisture, and pressure. The most basic building science is that warm doesn't always go up. Warm goes to cool. Moisture, it goes to dry. And pressure goes from a high pressure to a low pressure. So all of those, moisture, heat, and pressure, they can go in any direction to enter or leave the building envelope. A new requirement is that the building envelope has to be specified on the plans. It has to be very clear where the delineation from conditioned to unconditioned space is. In 2009, the last figures, there's 128 million homes in the United States. 20% of those were built before 1950 and had an average of R4. In the next decade, the insulation averaged 3.8 to 6.2. That was during the 50s. And then during the 60s, it averaged 6.2 to 11. So that's like 45% of all homes, and they go from 4 to 3.8 to 11 in the walls. So the building envelope is very important to control that. We'll see 2 tables in the energy code, the R factor and the U factor. R factor is the resistance to heat. So the higher that number goes, the better it is. But the R factor only applies to individual components. The U factor is the inverse, or the opposite. It's the ability to absorb and transfer heat. The U factor is for entire assemblies, like a whole window that includes all the components, the glazing, the sash, the frame, everything. That's the U factor. You can add R values, but you cannot add U factors. There's exceptions to the building thermal envelope requirements, very low use buildings, And this exemption is only for the building thermal envelope, not to the other mandatory requirements like mechanical, hot water, lighting. Also, basements might be considered a space that's not conditioned. And historic buildings, that all depends. You know, the code says it needs some type of designation from national, state, or local agency. But it depends what's being changed too. I know of one house that had a historic placard, but it was for an event that occurred on site. It wasn't the home itself. They wanted the whole home protected, but at the same time, they gutted the whole interior, right down to the walls. They were furring it out, replacing all the windows. Basically, all they kept was the exterior facade, which really doesn't even count for credits or elements. So that has to be considered by the authority having jurisdiction. Windows, you can see the change from the 09 to the 15 for the fenestration, skylights, and the solar heat gain coefficient, how those have tightened up, and their limits, regardless of what path is taken, the area weighted averages cannot exceed those. Solar heat gain coefficient is the ability of a window to be able to either reflect or absorb heat so that it enters the home. A high solar heat gain coefficient is good up north because they have more heating days, and you know they can open the curtains and let the sunshine come in and warm the room. Down here in Texas, we have much more cooling demand days. So our solar heat gain has to be lower than that. Lower is better. Another thing to consider is the VT number that is shown, visible transmittance, because that determines how much light is actually allowed to pass through that room. It's not heat, it's just light. So that if the curtain's open, then we avoid turning the lights on in the room. So visible transmittance, higher the number is better for that. Then with the air leakage, every penetration, every crack, every seam, it has to be sealed up. You see plumbing penetration around the windows and doors. Whenever air moves, it carries heat and moisture with it. And moisture can move through diffusion. It's actually moving through a product like the chipboard. But when there's airflow, it happens 100 times faster than diffusion. So that's real critical. For example, a 1-inch hole in a sheet of chipboard will allow 100 times more moisture to go through that chipboard than if you didn't have that hole. So imagine not a 1-inch hole, but a crack 6 feet long, 1/64 of an inch thick. Again, that's a lot of air, a lot of moisture. Whenever air travels through, now you've got a heat problem and a moisture problem. I saw an infrared image of a bedroom wall one time where it showed good insulation, but the air barrier had been broken. So air was passing back and forth. That made it a cold spot. It allowed the moisture in the air to condense, mold grew. And by the time the homeowner discovered what the problem was, the husband who slept on that side of the bed lost 40% lung capacity in 1 month. 80% of the problems with buildings and litigation come from moisture. The moisture problem happens without a tight air barrier. We can stop the air and keep insulation against the air barrier, and that will stop the moisture. Now, in these examples, when we have dissimilar materials, the sealing method has to be able to allow for the expansion and contraction differences in those materials. So a very rigid type of seal would not work well. Air leakage, this is important. Getting those air changes per hour down. This is one area that the builders have difficulty with, and the problem with waiting until the day the code goes into effect before they test for it, it slows everything down. They need to be starting right away, see if they can get to 4-inch air changes per hour. It all depends on the climate zone, but if they're practicing now with a good tester, they'll be able to identify what's causing the problem, and they'll be able to make adjustments. 5 air changes per hour is not difficult. In Canada, it's 1 or 2. And this isn't high pressure either, 50 pascals. A pascal is the weight of a very small postage stamp. If you think of a 25-mile-an-hour wind coming against a house, that's 11,000 pascals on that side of the house. And there's also a negative pressure on the other side. So when we're testing to 50 pascals, that's not too tight. That's a very reasonable and attainable number. Also with this, remember, there used to be just a very close inspection option. Now with the 2012 and the 2015, you have to do the inspection and the testing. So we test the ducts, and either at rough-in or final, and you test the total for the house. So a door blower, you see it there. Here are the air changes per hour, the differences in the climate zone. So most of the largest metropolitan areas in Texas, south of Hillsborough, you might say, are in climate zone 2. So it went from 7 to 5. And then north of that in zone 3, from 7 to 3, which also is up in the Panhandle zone 4. Now for the air barrier and thermal barrier, it has to be in substantial and continuous alignment with the building envelope air barrier. The insulation needs to be next to the air barrier. On the plans where we showed what the entire thermal building envelope was, that we need an air barrier in contact with insulation on that whole wall. Every part that where you have a transition from conditioned to unconditioned stuff. Ceiling or attic, it has to be substantially aligned with the insulation and any air gaps are sealed. You see this a lot, where they might make the walls tight, but the ceilings, there's some sections that might be entirely left out, knee walls and other areas. Space between windows and door jambs and framing has to be sealed. Remember, we were talking about controlling pressure, heat, and moisture in the home. That changes drastically every time the window's open, the door is open, kitchen vent hood, exhaust fan, bathroom fan happens. So all of those are taken into consideration, but it's made a lot worse by having cracks and holes. 10% of the air leakage occurs through windows, 14% through walls, 36% through floors, and 40% through the ceiling, attic, and roof. The insulation has to be cut to fit properly. If it's cut too short, then we have an air barrier without insulation. And then the air from the home, as soon as it touches that air barrier, which is colder, then you're going to have condensation. 75 degrees indoors with 50% humidity, the dew point is 55 degrees. That's a mild Texas winter day, isn't it? So if there's gaps in the insulation, that's where the condensation is going to happen. If the insulation is cut too long, then it's puckered. You know, it has to be forced in there, it has to be compressed. Basically, whenever you see the side of a stud, you know that the insulation wasn't cut properly. It's not aligned, it's not measured, it's not installed. The shower tub and exterior wall, this is important. Initially with the 2012, this is where a lot of them had difficulty and went wrong, because they had that whole area behind the tub, and it would just be open stud cavity, sometimes insulated. The best practice is to seal the exterior sheathing to that stud cavity, insulate it, and then a rigid air barrier, and then the tub. In order to pass those tests, and then you don't freeze when you put your warm feet in the morning into your cold tub. If you have, on all of these, if you have insulation without an air barrier, just remember it's like hanging a sheet. That's about all that you're accomplishing. You can double the amount of insulation, and it still won't make up for the lack of air barrier. So here's some areas that are often overlooked for insulation and air barrier together. See the cantilever window there? So who is it that has to account for that? Because what happens is that may go into an interior space that doesn't have insulation on the inside. So the outside here, this needs air barrier, this needs insulation. Again, the chases. Whoever touches it, that's the best rule. Whoever touches it needs to fix their work. It needs to be sealed. Maybe the plumber, maybe the electrician, maybe the framer coming back. I've been on jobs where the superintendent is just running himself ragged because he's running after everybody. We've seen that too, just burning through cans of pods. Right? Here's an example of what air leaks do with insulation. If your insulation is not in contact with the drywall, with chipboard, here's a fur down. You can see that lacks proper air seal and insulation. The rim joist, because the wall above and below has got insulation in it, but there's no insulation on the other side of that rim joist. It needs insulation on the inside, air barrier. Many builders, they use a rigid insulation on the outside as well. This is where that white dotted line is important because in the warm, humid zone, you can't put a vapor barrier on the inside or it's just going to explode with mold because of the climate that we live in. This is a new provision in rooms containing fuel burning appliances. Ideally, in a direct vented one, the combustion unit is sealed and all the air comes in and then goes out to the outdoors. There's not an exchange of air with the indoor environment. Anything less than this, then that room has to be isolated from the rest of the conditioned space. And any heating ducts or any water pipes that pass through that room, if it's isolated, then those have to be insulated as well. So a direct vent is ideal, as is shown here, but if it's a natural vent or draft vent, then the room has to be sealed up tight. Recessed lighting fixtures, this changed with the 12 code. It has to be rated for in contact with insulation. There's no way around that now for can lights. They have to be rated in contact. Otherwise, what they were doing is they installed the can, and then they'd have some type of mechanical means to keep the insulation at least 3 inches away. That's a chimney for heat to go right up through the center. If they didn't do that, then they would overheat the light and cause fire. So it has to be rated in contact, labeled, gasketed into the jet board, and they come with gaskets, but it also has to meet the requirement of ASTM 3. The manufacturer has to test it for air leakage because that is part of it from the building permit. Moving on to the systems. Here. There's an adjustment for heat pump supplementary heat, whole house ventilation. This went in with the 2012 code. A lot of builders are trying to figure out how to comply with ASHRAE 62.2 in order to get this whole house ventilation in. Most of them try to keep some positive pressure in the house as opposed to negative pressure. You're trying to offset all the exhaust in the house. And we'll touch on that. The design temperatures now are set using manual J. The HVAC contractor has to use 72 for heating and 75 for cooling. This keeps creative calculations out of the code approval. Everyone has to design for these settings right here, and they have to use manual J in order to identify what the load requirement is. Duct sealing is important. They have to be sealed in order to meet standards. Again, you can do it at rough, then it's easier to locate them and to fix them. Maybe they've just been pulled out of a transition box or the plenum, or how they're being supported is constricting them. It's a lot easier to find those at this problem. But at final, a lot happens between these 2 points in construction as well. So the builder has the option of rough or the exemption for this is if all the ducts are within the building. And we're starting to see some trusses designed for that, so that I use the wall over here, and they come across and then have a cutout for the ductwork, so that the mechanical equipment and the ductwork will actually be inside the building thermal envelope. And the duct testing does not have that. The ducts have to be sealed as well. Won't pass the test if they're not sealed properly. Framing cavities cannot be used for ducts or plenum, not even return air ducts, as was previously allowed. So it's not allowed at all. Spray foam insulation, that's an important thing. It's an allowable type of insulation on ducts, as long as it's sprayed with an incandescent coating so that it has some fire resistant capability. But whoever's spraying that insulation has to provide a certificate to the building official showing that it complies, like an evaluation service report. They can't just say, hey, I do. They've got to have some evidence of that. If not, the codes are very specific. If spray foam insulation is used in an attic and there's any mechanical equipment, you have to have an ignition barrier, which is like 3/8 inch gypsum. If there's any storage in that area where spray foam is applied, then you have to have a thermal barrier, which is 1/2 inch gypsum. And there's a whole list, 12 to 15 different things that can be applied. So when you go into an attic and you see the mechanical equipment, and you see all this plywood decking, and the spray foam insulations just billowed out from the other side of the roof, that is a code violation. Even the spray foam industry tries to educate their members for that. And I've shown it to several builders. I had a builder who only built out in the country. He said he's built a lot of homes. Apparently not in the jurisdiction, because when I showed him that, he just went berserk. He said, are you kidding me? I got to cut it. I got to sheet wrap on it. So it may not necessarily have to be gypboard on the bottom side of the roof, but it can come in. It doesn't mean that you're extending the building thermal envelope because the insulation is already up there. But you have to have either that ignition or thermal barrier, or it needs to be sprayed with additive or the incandescent thing. There's ways that the code is very specific how that can be done. Duct testness. The tests are prescriptive. There's no way around it. The rough-in test, you can see if there's a difference if the air handler is installed or it's not installed. If it's installed, the total leakage of 4 cubic feet per minute per 100 square feet of the home. If the air handler is not installed, you're just hooking up to a grill opening and you seal off the air handler would attach to the plenum, and it's 3 cubic feet per minute per 100 square feet. And the post-construction test, there's requirements on it too. Again, 25 Pascal. Just remember, 1 PSI is almost 6,900 Pascal. So that's not high pressure. In a house, even a one-story house, you do have some stack effect from heat, where when air expands, it's lighter and it moves up. And as it does that, it pulls in cooler air from below. So that's why the ducts have to be tested and the entire house has to be tested. Mechanical system piping that is larger than 3/4 inch has to be insulated. It's always been required if it's over 105, but now mechanical piping that conveys fluid between 55 and 105 is exempt. So if it's below 55 degrees or 105 and over, then it's used to be insulated. It has to be protected too. The code says sunlight, moisture, weed eaters, and wind. How many times have you been to a commercial residential building? And from the edge of the building to the outside unit, those lines are just amazing. Everything's been weed eated off. So adhesive tapes, you can't just wrap it with electrical take, it has to provide some meaningful protection. Heated water circulation and temperature maintenance systems. These are, you see, the controls have to be accessible. Just like the electrical code requires any disconnect, you have to have clear working space in front of it, 36 by 30 inches. Manual controls have to be readily accessible. The difference between accessible and readily accessible means you're not allowed to have to remove a panel in order to get to it. Accessible means you can have a panel, an access panel. But manual controls, someone might need to get to that switch quickly and not have the screwdriver in their pocket. Demand recirculation systems. We'll get into how this affects hot water heater. First thing in the morning, you open up the cold water, the hot water tap. You want to shave, or you at least need hot water to wash your hands. Usually, all that water just goes down the drain, right? Well, there's a new provision. We'll get to that I'll talk about it on this slide. We'll get to it in the next section, but here, the hot water recovery systems, it uses a series of pumps instead of city water pressure, so that when you open the hot water faucet, it's not going to come out until it's at least 104 degrees. The water that was at one time warm is pumped back through the cold water lines to the water heater. That way you save energy, and you save water, and you save money. So there's requirements on these circulation pumps. We'll start either on a signal or a user or a time of flow. It has to be set properly so that it's not running when no one's in the house. There's integrated loop systems, and there's also intermittent systems that periodically will run that hot water through the system. That way it's hotter and quicker. The only problem with that is the cold water is a little longer than you're used to. That easily goes to cold. And the thinking on that is all that water, instead of sending it down the drain, it goes into the water heater. It's already tempered because it's in the building thermal envelope. If it didn't do that, then you've got frigid water coming from outside. Hot water boiler outdoor temperature setbacks, another energy setting device. And this is, it says a mandatory requirement. It's only if you have a hot water boiler outdoor. And again, the purpose for this is, there's months in the summertime where you might not even need any cold water to take a shower. Hot water to take a shower. It comes out warm out of the cold, right? So in the summertime, most of the hot water that's needed is in order to temper the cold water to make it comfortable. So this is just based on outdoor temperature, that boiler can lower the temperature of that hot water because it's really not needed as much to warm up the cold water. Drain water heat recovery units, again, they have to comply with these two requirements. The first one is for the fabrication of material. The second one, B55-1, is that it's tested and labeled for efficiency and it meets the pressure loss requirements. On residential buildings, you can't claim credit for the recovery of heat for this. The Energy Code has requirements if one is installed. Ventilation. It has to meet the requirements of the residential code or mechanical code. If a unit is oversized, then it's going to waste money in every step of the way. It's going to cost more to buy, it's going to cost more to operate, it's going to be less comfortable, and it's going to wear out quicker. The reason for that is because when an oversized unit kicks in, it's going to cool that temperature down fast, but it won't run long enough to remove the moisture. So oversized units are associated with more mold growth. Because it's cycling on and off and on and off, then that's going to make it wear out quicker. And for decades, residential units, even in Texas, 50 to 100% oversized. You know how it is. When we get home, we want to see our breath. as soon as possible. But it's just not efficient, and it's not any savings to the homeowner. So the calculations by the HVAC contractor have to be done with manual J in order to determine the load. And then they have to use manual S in order to select the proper equipment. Both of these together are required, and both of those together are used in order to avoid oversizing. Remember, you get back to moisture problems in the house, and that's associated with oversizing. Now, the programmable thermostats, that was in the code before '09. In the 12 code, it adjusted it, and it said for forced air units. That came out in the 15, and the 15 added that it has to be preset by the manufacturer. Because many times the thermostat's installed and people never touch it. So it's preset by the manufacturer. It has to be programmable for temperatures at different times of the day when everyone's at work, school, or they'll be able to adjust it for vacation without changing all their particular settings. Another requirement for heat pumps. Heat pumps will save, they'll use about a third of the energy of a regular electric HVAC unit. But that's only if they're used properly. If you've got an individual in the house doing thermostats, turning it up and down, then this automatically locks out that electric resistant heat based on the outside temperature. If the heat pump can meet the requirement, then that electric resistant heat is locked out. And then for fireplaces, I made some adjustments to this slide to correct it. Because from the '09 to the 12, the codes never said gasketed dampers or doors. It was put into the inspection table for the air leakage of the building thermal envelope for fireplaces to have gasketed doors. Problem with that is most manufacturers did not have any gasketed doors available because they affected the performance characteristics. A lot of them had overheating problems with the appliance, especially with the field attachment. So this right here, the code, if you look on yours, both of them are 2.4.2. If you want to make that adjustment on your slide. So the requirement is wood-burning fireplaces, whether it's masonry or factory built, they have to have tight-fitting flue dampers or tight-fitting doors, and they have to have outdoor combustion. For the tight-fitting doors, masonry, they have to be listed and labeled for UL 907. For factory built, they have to be listed and labeled for UL 127, and they have to be tested and listed for that specific appliance. That's critical. Without any doors, and there's a fire in the fireplace, it just sucks all the conditioned air out of the house, it sends it right up to the chimney. It's just a great suction. And then why have the fireplace running at the same time the furnace is for all the other areas of the house? And then there's requirements for pools and spas, both a permanent spa and also portable spas. One of the important ones is the accessible switch. Right here, again, it has to be accessible. It can't just be a circuit breaker, because a circuit breaker will cause the whole thing to reset. And it can't be one that requires a new temperature adjustment. So you can't have an on-off switch that is the temperature dial as well. So that it's off, and then you turn it on, you turn it to the desired temperature. And the requirement for vapor retardant cover is for all permanent spas and pools unless 70% or more of the heating is from on-site. So I think I tried to go through that at a good clip. So I think we're close to break time.
Yeah, David, good point. So I think we finished through the mandatory requirements. Before we take a break, we've been at it right at an hour. Maybe go back and since we have some time, we're pacing ourselves here. Let's go ahead and see if there are any questions back on page 4 of your participants guide. the new Texas Administrative Codes and the Texas House Bill. Maybe take a minute or so. Does anybody have any questions or comments on that page, on those two slides, that you'd like for us to address? If not, then page 7 is, again, important. It's what's new in 2015, and then on slides 14, 15, which is page 8 and 9 in your participants guide. Any questions on those summaries?
I have a question there.
There you go, David.
So on page 4, the state adopted 2015, but they adopted it with certain modifications. When are we going to see those modifications?
The second. I'm trying to cover, every compliance path has to meet the mandatory requirements. So we hit the most significant of the mandatory requirements now. So now after break, then we'll break off under the prescriptive path, what's required on it, the performance path, the energy rating index, or any alternative code path. So that's what we're going to address. They adopted 2015. You can't change the residential code for another 6 years. The health and safety code, we'll get into it later. It requires that if any jurisdiction adopts the code with amendments that would appear to be less stringent, those have to be validated by Energy Systems Laboratory. Remember, any higher jurisdiction, when they lay down the law, jurisdiction below them, they can make it more stringent, but they cannot relax it. So we've got federal, we've got state, and we'll have authority having jurisdiction. Each of those can make it stricter and stricter every time they adopt it. They can add things, they can take things out. So we'll see where the state relaxed the energy, the ERI requirements, the energy rating index. The jurisdiction can make those more stringent. They can say we need these different requirements met. So that's why it's important to not just familiarize ourselves with the energy code, but also the state requirements and then the jurisdiction.
Page 21 or 22, I'm not sure. We talked about the percentages of loss. All of those, what they were, like the window walls.
Slide 49 and 50.
Oh, 49.
40, 49, 40 and 41.
Yeah, air leakage through the building thermal envelope, 10%, and this is what the test has found, 10% is through the windows, 14% is through the walls, 36% is through the floors, 40% through the ceiling, attic, and roof. Sure. So basically, less than a quarter of it goes sideways, more than a third goes down, and the greatest portion goes up. And that all depends on the building science. How much air leakage you have, it allows more air movement in the house. If your air barriers are tight, where it's going to leak out, it's going to be through the sides or down. In the second half, we'll get into insulation and air barrier and moisture controls. Floors. Again, what we addressed on the first part was all the mandatory requirements. The certificate, air leakage, having to identify the building thermal envelope, the maximum refractor and solar heat panels, controls, duct sealing and testing, no cavities used as ducts, mechanical piping insulation, mechanical ventilation, mechanical sizing and efficiency, lighting equipment, all of those are mandatory. Also, if that site has hot water recirculation, snow, ice melt, permanent pool permanent, or portable spa, or gas lighting. The code also has mandatory requirements for those, and we'll address those in a second. So every path has to meet those mandatory requirements. After we take a break, we'll go down each path and look at the particular requirements and also flexibility.
Any other questions in the last minute before we take a break?
I have questions about the air barrier. Basically, how the air barrier does or does not differ from the normal envelope.
Air stops the movement. The air barrier has to stop the movement of air. It does not equal insulation. Because the fiberglass insulation will be a permanent. That's why it can't be used in order to seal cracks
Right.
and holes. So if you don't have the air barrier, you just have the insulation. Basically, it's just an air filter.
Right, got it. Okay.
Because air will still go through that, moisture will still go through that. And from the indoor environment, when your warm, moist air is going through your insulation, as soon as it hits one of those building components at the dew point, now you've got condensation. Now you've got mold.
So your air barrier may or may not be where your thermal building envelope is.
They have to be together. You have to have air barrier and insulation everywhere you identify your building. Otherwise, you really don't have an envelope. An envelope equals the air barrier and insulation.
Right, so say in an attic, you have an air barrier, you have your air barrier going up your wall, and your soffit, you have the vented soffit, and then you go up your roof, and you have an underlayment, which is your air barrier. But then you have a vented ridge cap, but then your insulation is down at your rafter, your ceiling level.
The outside of the building protects against fault water, like rain, but that's not your air barrier. Air barrier is inside, whether it's siding, brick, or whether it's the shingle roof. So on that, where you've got soffit vents and baffles, it goes up through the ridge vent, your insulation and air barrier is the ceiling.
Okay.
That's where you've got to stop the movement. That's why if you're up in an attic and you ever pull up that insulation and it just looks filthy, it's because it's just an air filter. You've got air going up through it. It's holding all that. That dirt wasn't there when it was installed. That's an air that's moved through.
So where in the code does it define air barriers?
Well, you've got to define your building envelope. That's where it leads it up to the building. You've got to have your. Let me see if I can answer that in the slide.
So air is going through the attic and your air barrier is down at the ceiling. Got that? Okay. So then the air barrier is the chipboard?
Chipboard and your awning, your taking clothing. It's like behind the fireplace. That's required to be air sealed now. So depending on whether it's inside or it's an outside wall, as to how you do that, but we require builders to they have to be insulated, they got to poly seal it, and then they've got a chipboard. And so now that's an air barrier.
It's easy when you're outside, you can seal your plywood sheathing or your OSB, you can seal that, but then when you get in, that's, I guess what my question is, if it's at that chipboard,
It's at the chipboard.
then you don't have to.
That's one of the most notable places where you can see cracks. And that's why the requirement for attic access is that those have to be accessed.
Okay, got it.
So your air barriers, your chipboard, your paper floor, your insulation there. We're in that unique zone where we don't make it real tight there because we don't have. But through the normal building process, your chipboard, that's your air barrier. The thing with the code though is, you get almost,
Okay.
so there's a difference between shedding bulk water your brick, your siding, roof, and then actually having air barrier.
Excellent. Thank you for the questions. As we take a break, please remember to fill in the sign-in sheet, if you would, with your name, email address, and your CEUs requested, as well as your address on one of those large index cards, so we can ship your code book to you, just as a reminder. And any questions you may have, feel free to write them as well. So we'll take a break for 10 minutes. It's 10:20, and we'll come back at 10:30 for moving into the prescriptive path section.
That's the section.
You can stay for the commercial. That was a question I was gonna ask you because I
Yeah, you're right. Greg, you know how many signed up for the commercial inspector
session later.
Um,
This is Bernie.
You thought
You signed up?
Great. It should be fine. I think before the registration closed, it was just at 10.
Okay.
So you'll be fine.
Okay, what time does it start?
They'll start at 1 o'clock.
1 o'clock.
And we'll have you sign in again separately for that.
Okay. All right. Yeah.
As a plan review or two.
Commercial, I thought I was, but it would get these things.
Oh, here, right there. Absolutely. Thank you very much.
Defining, our values. They accepted the second one?
I don't know yet, I just put it back in. So I know what this is, I know that means.
How you doing? Greg Hall, nice to meet you. You from here in San Antonio? Oh,
Just into this, interview process.
is that right?
Yeah.
Oh, good.
I mean, a lot of involvement, environment, construction, going on right now.
Sure.
I know also the document already, San Antonio. I get the document now, but they'll get out of line.
Yeah, exactly.
But,
You know, a lot of it is
Your
just
barrier.
knowing what to do. It's the information. There's so much of it.
Exactly. No,
So you have to learn the information, but you still have to do your job too. That's the challenge.
well, we did a Nike program, and for some of the resume programs,
Oh, yeah.
radios and assessors and so much stuff. We call all the time, but that's it. Good boundary.
By the time we learn it all, our kids will be taking on it. Get it done 5 times as fast.
And you would think over IRC every 3 years and IECC, everybody knows like time is changing, code changes.
You know, and the challenge is learning is like still having to produce work here.
Exactly.
Taking the time, downtime. You can make up. Sure. For you guys, back in the day, we just do all the weatherization training.
Oh, really?
Yeah. My guys, I had about 20 guys going on with the 5-day basic weatherization.
Turbo, you got some installation. That's what
Still doing it.
code requires.
We did all the training.
Installation, that's what you're talking You're building that.
Yeah, they are. Although they've asked us to start up.
Right. See you later.
Yeah, that would be awesome. We're gonna start doing this.
You know, before they apply the chip board, you want
All
all
the
the
state.
stake when they're all on slab, demonstrations.
Texas,
Email up to Jim Ward and take him to it.
hasn't had a weatherization training academy at state level, specifically for the lab.
Also, the adoption of standards for Texas. It's like we have no other standards.
It always has to be adjusted.
Yeah.
We did it.
We're almost just as concerned about our kids as they're. It's like,
Kids that they-
Yeah, most of the weatherization building science experts are all from New York or Montana.
That's right, because now that's
A good friend of mine, he wrote Presidential Energy, John Rigger, who loved Presidential Energy. Chris has worked for me in the last couple of years. All these guys, 30-year experts, they're all.
Yeah.
One guy is actually Doug Garrett. He's a Texas guy, but he stays with us. He had a chance to buy it.
So,
But we've got, so that's, we're the department.
It's not a voice thing. You can't put
Things
flags.
have been a little calm last couple of years, but we're actually now with new DOE requirements that came.
yeah, we're all hoping to get our QCI.
Yeah, but we're doing that in Austin.
Eva's taking it next month, actually. I'm hoping to take it after
Up
her.
in New Mexico.
She is going.
You can help with it.
They've got the only training center, so we are officially launched in Austin. So we're actually getting, I've been talking to Sharon Gamble with the TDHCA, Marco Cruz. We're trying to get the word out that everybody can come.
Really? I know my bosses would love that.
It just got approved.
So when you guys can open it?
We probably start doing it next month.
Really? Ever? They're gonna do QCI.
It'll be the QCI in Austin. We've been working with Sharon Gamble, Marco Cruz, and Laura Sankey. Yeah, so we're now the DOE training center in Texas. And we just got our IRAC. Providing Smart Academy. We train all those.
There's, if you look in,
And that was in their report, their.
Bill Eckhart.
I've got this, what's required, I have it on my computer. What's required by the spray foam industry.
So what we're gonna do, so we're actually gonna be doing the PCI in Austin starting next month. And what we're gonna do is get preparation, online preparation ahead of time. Everybody, so it's a difficult test. So we've been working.
And then how long is your training?
So it'll be a 4-day training, it'll be 4-day training with the field houses. Testing.
Just, yeah, 'cause I took my resume.
Yeah.
It's kind of the same setup, but she said she's only got 3 days of training.
But they do some prep before you get there, but you do it all day, 3 days of training. Yeah, the test. So we're going to be offering some online stuff ahead of time. Even so live, so preparation. Yeah, exactly. Preparation. We've been working with the Department of Energy since August. So we're the Department of Energy Conservation Training Center in Texas now. Just got a lot of
Well, I know Myra.
Actually,
Tomorrow.
next week's getting the word out to
How
all.
about you starting on?
Our bosses will be there for tomorrow's class.
We've been doing that.
Right, you can come to our facility, at ACON, get that.
Good, how about
Plenty of time.
The last couple of years, it's been a little quiet.
Right.
Now with the QCI, they asked us to bring things up.
I'll say this.
Save money and a trip.
Yeah.
So I'll let you guys know.
Okay, great, be awesome.
But like I said, our supervisors will be here tomorrow.
Good. I'll make sure,
They'll really like to hear that.
make sure that, like, have them mention, ask us about.
Yeah. 'Cause that's one of our biggest holdups. We want to get everybody certified. But it's so expensive for us to send somebody out of state.
And then,
Food,
car,
car.
and then a chance to.
I know. Well, this is her second try. Supervisor. Costs through the roof and
That's
that.
what we've been here. That's why John's like, he's a guy who'd be doing training.
10%.
Right? He works for 14%.
Oh, your phone?
Yeah, he's been on weatherization since 2000.
Yeah.
He does media, all the weatherization courses. But I'll let them know.
Yeah.
I'll just take a break. Yes.
Second.
Yeah.
It's not popping off.
I'll see a picture.
Which, yeah.
They make it any length they want. You just have to start and finish off the those pieces.
Yeah, that's good.
Yeah, that's what I was looking for. What I did, I started, I figured it was 6 weeks long.
Yeah.
And I put, I can see it.
Texas, I'm sure. That's all.
Go ahead.
See that. Yeah, I looked it up. It says same per day meal. Do 3 weeks of mine.
Yes. So this is what we do.
Either all week, or just get it done. I can sort of Not specifically. We're here next John now, right? Yeah. Show's pretty good lunch.
Right across the way. I feel like
Plenty of spots.
Zoe's Kitchen. It's pretty, it's like Mediterranean kind of health food. The salads are great.
I think we're ready.
See the pictures in the press.
Yes, we did.
Otherwise, I could walk up there. That's why I'm carrying screen. Okay. Everyone back? I apologize when we started that we didn't do proper introductions. I introduced myself, but I'd like to find out who you are and why you're here. That way we can appreciate who our audience is. So let's start here. We'll start with you. Tell us who you are, who you're with, what you hope to learn today.
I'm Mark Dave, I'm Portland County, I'm very focused on business.
You be here this afternoon, too? Next.
I'm Allison Huxtable, I work for the state energy conservation office, which is one thing that we hadn't gone through a final run through, so I wanted to see what it was all about.
She holds my lead. Tell her what you think. Sir?
My name's Lee Smith. I'm a business owner. Just kind of temperature here inside.
Hold the world.
Oh, yeah, yeah. I mean, it's way different from, the other side of it, construction, a lot of change. I'm kind of taking some of it.
So you can see it will be reference.
I see a lot of houses, a lot of builders, whatever, you know, but all the code changes, you know, kind of dealing with that. I can see it from my side of it, the special side of it. And maybe to the builder, this perspective of it. Like if I come to a debate.
You know what they say about arguing from expected, right? Wrestling with the pig in the mud. You're wild, you find out
Those some of the things about like jurisdiction. On state level.
It's very, very important going into a jurisdiction.
I'm part of there, I'm an architect, and part of our practice is residential. And mine is a great consultant to say, I could recommend him.
My name's Kevin Burke. I'm a resident, HERS Raider, also a Building Performance Institute and below guy and all that. I started my own business after retiring from the Army back in December. I operate up in Bernie and Purville, climate zone 3.
There you go.
Hi there, my name's Scott Carpenter, I'm seventh generation design and my partner. In addition to this, I also do a lot of school administration. And so one of my interests is how these are integrated into find the right balance between what is historically significant and also bringing it up to.
My name is Drew Sutter. I work for Ecos Energy Advisors. We do mostly energy rating, curve rating, new stuff. Mostly existing housing except for code testing, stuff like
My name's Andre Furman. I work for ACOG and the weatherization department. Assessments and audits. Southwest and lower north, creating audits. Also inspect the finding, so just making sure we're up to keeping all the codes standards.
Evelyn, I work for Alabama Area Council of Government. Same with Audrey. I do initial assessments. I do spot checks, installation in progress, and final inspection. We have to follow local code, or contractors have to follow local code. So, get educated. Thank you.
Gentleman that stepped out is in witness protection. He's one of the trainers with Apple Energy.
They found him on GPS.
Okay.
You guys met me earlier. Greg Hall with Apple Energy Group in Austin, Texas.
And our host,
Yeah, Roger Casey with Burgess Construction Consultants. We are a third-party inspector. We're all combo certified and HERS raters, and we have QADs on staff and do a lot of energy analysis.
Hi, I'm Mike Lackey. I'm on the Apple Energy team. I'll be conducting the commercial version this afternoon. Thank you, Mike. Thank you. I'll be sitting down this afternoon. And I'd like to get your business cards for you too. I always say anyone in the business always needs someone they can call and ask questions. We try to make ourselves available for them too. We appreciate you coming. I apologize for not getting you to introduce yourselves at the beginning. So we talked about all the mandatory requirements. Now there's different paths to compliance after the mandatory requirements. Prescriptive, simulated, ERI, and then alternative paths. On the prescriptive, there's actually 3 ways to comply with the building thermal envelope. You can use R value of all the insulation materials. You can use the U factor of all the assemblies, like framing, insulation, wall. Or you can use the UA alternative, which is the sum of the whole building. Those are ways to comply with the building thermal envelope. So we're talking a little bit about break here. It's required to identify the building thermal envelope, which is a combination of insulation and air vent. That's what it is. So it has to be very specifically shown on the plans that are submitted to the city. That will help the plans examiner move your project through. The more you can put on the plans, the better. The more specific it is, the better, because if the plans examiner gets bogged down, he's going to set aside. He's going to work on something that insulation and fenestration requirements have R values, and again, R value is based on a specific component. It's one piece. Whereas the U factors, these are the entire assembly. For example, a window is an entire assembly. The glazing is rated for solar heat gain coefficient. Visible transmittance, how it's sealed into the frame, gasketing, gas between panes, all of that whole thing is an assembly, and that's what's listed in this table. Solar heat gain also has to be met. Where R values can be added, U factors cannot. Of course, we want the highest R value that we can get. We want the lowest U factor. Let me go back one slide. This is, you can use the alternative here or the entire envelope. And what you do is it's the average of all of the components, as long as it meets the minimum of the table. So some can be a little worse, some can be a little better. Each component is calculated by its area, and all areas are added up and divided. There's exemptions for the R value. These don't count for the U factor or the UA alternative. 15 square feet of glazing or 24 square feet of siding doors. So this will account for side lights with the door assembly. This will account for kitchen door. Mostly we're talking about decorative glass. That way the residential door doesn't look like a commercial. So this exemption is allowed. For dynamic glazing adjusts throughout the day depending on the amount of direct sunlight. You see there's a ratio for the solar heat gain. It has to be equal to 2.4 or less. The exception on this is if the high level and the low level both comply. It has to be automatically controlled instead of manually, so that when no one's home, you still get the full benefit from dynamic glazing. This is the prescriptive path. See here, the energy truss we'll look at in a couple of slides, we'll look at how it benefits, how far out the insulation can come over the wall below so that there's not a gap. The code allows, if there's a short space, you look at cathedral ceilings, vaulted ceilings, there's an exemption, 500 square feet up to 20% of the insulated ceiling area. If it doesn't meet that requirement, then you have to go back to the drawing board to increase the depth of the rafters, some way to accommodate insulation requirement. So it's not the whole ceiling, it's only a proportion that's allowed to do that. See an example of beautiful ceiling. This allows builders options in order to make that, but again, the requirement is 500 feet max or 20% max, whichever is less. Then the eave baffle, you see here the energy truss. What good is blown-in insulation or even bats if they're all crammed in right up against the underside of the roof? So the baffle is required so that the air from the soffit can go up above the insulation level and then come out to the ridge for gable vents, or if there's fans up there, whatever. That way, this doesn't become a semi-permanent. For attic hatches and doors, they have to be sealed, and they have to have the equivalent R value of the surrounding area. Most of these are built on site. There are products out there that can be bought, even for attic access with stairs, drop-down stairs. But it can't be ignored. I've seen insulation contractors where there's no insulation, no thermal value to this, and they actually crammed insulation in the stairs. So it was hard to go up the stairs. I'm in the attics a couple times a week, and one on Saturday. Yeah, it's even months ahead talking to builders. Listen, you got to start working on a way that you guys can do this. It's real simple. You have to have a retainer for the loose fill insulation so it doesn't come down. Basically, it has to be durable. It has to be permanent. So that if they open the attic once or twice, they haven't lost the R value for most of that wall or wherever it's located. It has to be sealed. Above grade walls, what's missed a lot are the rim joists right here. The walls are insulated well, but then you've got a 2x6 on the side, and there's no insulation in the cavity. So this is where you're going to lose a lot of the condition, the value of the condition there. So the inside should be insulated, the air barrier. Most builders now use a rigid board insulation on the outside edge. We'll get into crawl space requirements. This is a code requirement to reduce the value of siding insulation. And the reason why is because we've defined on the plans where the building thermal envelope is, the air barrier and the insulation. Usually what's outside that and on the inside of the studs isn't counted. Jib board is almost R1 in value. The code doesn't allow us to count. We don't count the R value of brick or whatever. So if insulated siding is used, the labeled value, see this is 2.7, you don't get to count 2.1. It has to be reduced. So that it doesn't discourage the use of it. The whole purpose of the code is to allow room for innovation, and allow room for new products, but to establish a baseline. With mass walls, you see that the insulation location is important. At least 50% has to be on the exterior or integral to the wall. You want to hold the cold out and the heat in as far away from inside as you can. More than half the insulation's interior, then the required values you can see there are increased. So mass wall requirements. Steel framing. Steel is an excellent conductor of heat. That's why they make matches out of wood, not metal. 400 times more heat than wood. So basically, it's like using a koozie, trying to keep your soda cool in the middle of summer. And about the only way to do this is with rigid insulation on the outside. Floors over an unconditioned space. The floor insulation has to be in permanent contact with the underside of the floor, or it has to have the minimum R value continuous from top to bottom, and then continuous insulation. So if that's not in contact with the floor, then an insulation that's the same thickness as the floor joist is used, and then a continuous insulation, like rigid insulation, along the bottom. That way, the purpose is to keep it from sagging and creating an airspace between the floor decking and the insulation. Remember, insulation has to be at the air break. Crawl space walls, there's here, instead of insulating at the floor, insulation has to come down the walls and extend 24 inches. Earth has to be covered with a vapor retarder. It's overlapped by 6 inches and sealed, and it has to go 6 inches up the wall. There's a chart here that shows the different requirements for vented and unvented crawl spaces. The bottom two are probably the most critical. And, the ducts being sealed, and the mechanical ventilation required. If it's not mechanically vented, if it's open to the outdoor air, then it has to meet the requirements of the residential code. It's 1 square foot of opening for every 150 square feet of crawl space area, as shown here. So you don't have to count underneath the front porch. You just count crawl space area as what's under the conditioned space. Here's a good diagram of how the wall construction is required. As you see, sealed vapor barrier, insulation. Grade has to be sloped at least 6 inches and 10 feet. This has to be net. I've seen some that come down and then they go up. And with all these high, we have drop, and all of a sudden we've got terrible rain, waters this high. So it has to have a reasonable way of moving that down to the street, not onto adjoining properties. Air gap allows for capillary action, shedding water from the outside. And also, if you look here at termite inspection area, so you can look for those little tubes that go up. The code defines areas in the state that are rated as heavy or moderate for termite damage. Duct insulation is prescriptive. If they're larger than 3 inches or 3 inches, R8 in the attics, R6 others. Less than 8 or 3. If they're greater than 3 inches, it's R6 in the attic, 4.2 elsewhere. No trade-off for this. And remember, if this is in a mechanical area or storage area, then that has additional requirements. Additions, this is addressed in the new chapter 5, and it's at the end of the book. Basically, you have 2 ways of dealing with this. You can treat the new building all by itself, ignoring the existing wall that connects them. Or you can count the whole building together. If it's a newer home with an addition, counting the whole building will work. If it's a real old building, it may be very difficult to make that work. And this is just the requirement for the building thermal envelope, the other mandatory requirements, HVAC, hot water, lighting, all those requirements. Sunrooms, this changed with the 2012 code, have to be thermally isolated. There's requirements for the glazing area, separate HVAC, and the fenestration requirements for the sunroom. And the room that is common to the sunroom and the house, that would still be the building thermal. Lighting equipment, this was new in 2012. With the 09 code, it was 50% high efficacy. With the 2012, it made it clear that 75% of the lamps, so like this fixture above me, it's got 2 lamps. Each individual, what we would call bulb, code, that's the lamp. Or it would be 75% of all the fixtures. Have to be at least 75% high efficacy. It also requires any gas lighting that's used, like a decorative yard gas lighting, no longer use a continuously burning hydrant. The reason for the new high efficacy is because they're so much more efficient than the old incandescent. The incandescent bulbs, 10% of the energy was used to produce heat, and light 90% was heat. So basically, you lost 90% of your energy with those. The code does define what is a high efficacy lamp based on lumens per watt, based upon the wattage. When you're shopping for lamps, use the color rendering index. 84 is very close to natural light. Kelvin is the temperature, and that controls the color. So if someone likes more pure white, you can go from 2800 to 3400 Kelvin. That would give them more pure light. Some people want the new bulbs, but they're still so used to the old incandescent light. So you can adjust that as you tweak the CRI. So those were the prescriptive paths. We'll talk about this UA alternative. Remember, with the prescriptive, we just talked about there's 3 ways to comply with the building permit. Strict R value, or you can use the U factors, or now this UA alternative. And this is the total building thermal envelope. It's not just insulation. It's not just windows. It's your framing. It's everything, so that it gives you the greatest flexibility. You can use the fancier windows that aren't as efficient if you have more insulation in the walls, things like that. So the U factor alternative, again, basically the entire assembly will be equal to or less than table 402.14. And it allows trade-offs. ResCheck is a program that's provided free. We encourage people, when you get into these performance paths, let the software do the calculations for you. Make sure that you've got the right version of it. Okay, we'll move on to simulated performance alternative. So this is the second. Again, we have to follow the mandatory requirements. And now the simulated performance alternative. There's ground rules for it. You have to use computer software. But now you have allowances for orientation. You know, whether the building is facing north, south, east, or west, or if it's not on those cardinal. You're comparing a house built to the prescriptive code to the house that you want to build. And the result has to be based on the energy costs. So the architect can design a real fancy, unusual, innovative house. And as long as the energy costs are equal to or less than if that house was built to the prescriptive, then it will comply. It allows, there's more trade-offs, there's stricter documentation. And the reason for this is because what we expect in homes, it changes. You know, when our grandparents were in a home, they didn't think much about wearing a jacket. They were in the house sitting around an old Franklin stove. Now we want our house, we want to be able to walk barefoot, you know, in our shorts any time of the day, feel comfortable. And you know, we might want a lot more glass. We might want an earth home. Simulated performance, it allows a lot of alternatives there. Shading, passive solar. There's allowances for thermal mass walls, ducts, high efficiency HVAC and water. But again, remember the mandatory requirements still have to be met.
So that sounds like red rate software, all right?
Yes, and we will get to that. Rim rate, for those, is proprietary. HERS raters use it, but not the general public, right? So it's one of them. We'll get to that. So the code is very specific as to how to multiply the energy cost, because that's what this performance is. We're comparing what it's going to cost to run that house on energy. So for electricity or other than electricity, the code is very specific for that. Multiple orientations, this is good for production builders. If they do a simulated performance and they provide their results showing that it complies with all 4 cardinal orientations, north, south, east, and west, then the code official is allowed to accept that for any orientation. He only has to do 4. He doesn't have to do, show that it complies north, northeast, or something like that. So this is a benefit for production builders. For different sites, you have to use worst case conditions. Again, the input is going to determine the output, so this is important. Compliance report, remember we talked about this, that there's an inspection checklist for the permit. But then also for the certificate of occupancy, we need what we would call the as-built. We would need to show that it still met those requirements. So this is it simplified. You've got the standard design built to the prescriptive path, and the energy cost would be to operate that house. And then you make some adjustments with your windows, your insulation, all the other things that we mentioned, your HVAC, your water heating, even renewables, put them in, and then either is going to give you pass or fail. Okay, it's either equal or less, then it passes. If it's going to cost more than the standard design, then it fails. And the different ones, we said rim rate is proprietary. HERS raters use that. Energy gauge, also the free ones, IC3. This was developed by Energy Systems Laboratory at A&M. It's an excellent program, and by September 1st, it'll be able to handle the ERI, BOPT, and of course, Department of Energy, the res check. You have to have software to do this. You turn in all the calculations, the plans examiner probably isn't going to be ready for it. He just wants a compliance report so that he can verify what the inputs were. It's the right code edition, it's the right climate zone, and it's the right version of it. The reason why this is important is because, remember we said our values can be added, U factors cannot, and then you get into averages of those. For example, you take an area the size of a sheet of plywood or sheetrock, 4x8, and you've got R8 on half of it, and you've got R2 on the other half. What's the average? Well, it's not as easy as we think. If you put R2 on top of R8, you have R10. You can have it that way. But if you've got R8 right next to R2, the average of that is actually R3.8. So that's why we want to use the software so that the building official or the plans examiner will be able to verify it. The next compliance path is the energy rating index. Again, it has to meet the mandatory requirements. Before, there were a lot of programs that use the energy rating index. HERS raters were along existing well before the 2015 Energy Code, but there wasn't a governance on it or setting scores in the code. It requires strict documentation and a review. Seen stickers like this. The energy rating index is based on the baseline of the 2006 Energy Code. It compares this current code to if we built to the prescriptive requirements in 2006. 100 is, okay, we've achieved the 2006. 0 would be a net zero energy home. So If we were at a 40, score of 40, that means it's 60% better than the 2006. If we were at 70, then it's 30% better than 2006. So that's what the energy rating index is all about. So whatever the index is, you compare that to 100, and that's the efficiency of it. The example here, if it has a score of 130, it's 30% less energy efficient than a home built on the 2006 energy code. So that would not be acceptable. That would be rejected. So the model code sets for climate zone 2, energy rating index of 52, 51 for zone 3. I don't know of another code that the builders complain about more than the energy. So you see the sliding scale that's been put in, that instead of needing 51 or 52 in zone 2 or 3, that September 1st of 2016, it's 65, which means that home would be at least 35% more efficient than home prescriptively built to the 2006 energy. 3 years later, it gets 2% better. And then 3 years later, it's 4% better. But you see, it's still not to the model code. This is where we need to check with the authority having jurisdiction, because they can adopt and they can make this more strict. They can completely eliminate the sliding scale and say that all homes built in their jurisdiction have to meet the model code. Or they can have these tighter. They cannot, again, they can't relax these. Mandatory provisions for water heating of the 2015 code still have to be met. And the building thermal index, envelope and solar heat gain requirements of the 2009 code still need to be met. And you're not allowed to use the solar for the energy rating index. In using this, we're allowed appliances and things like that. We don't want to, for best practices, don't use appliances to offset your envelope or your windows. Because your envelope and windows, they might stay in place 50 years. That appliance might be replaced in 5 years. And we have no control over what's put in there. So it's possible that with the changing of appliance, now the home isn't code compliant, and it isn't going to give them the savings that they expect. The appendices in the 2005 code, the first one, the appendix RA, what this is that building pressures affect the atmospherically vented appliances. So like water heaters, furnaces, things like that. The pressures in the home can reduce the air exchanges, it can cause incomplete combustion, buildup of carbon monoxide, which would affect indoor air quality and safety. So what it does is it calculates the maximum of all the exhaust fans, the kitchen vent hood, laundry exhaust, bath exhaust, air handler, chimney, and basically it's a combustion safety test procedure to see how the building envelope is affecting those natural draft appliances. So it's helpful. It's not a requirement, but it's informative. The second appendix RB is for solar-ready provisions. This is not a requirement unless it's adopted by the authority having jurisdiction. And the purpose of this, the Department of Energy's Sunset Initiative, they want homes more solar. They want solar energy to be more competitive. They want to make it easy for people to install. Okay, without having to add later for the additional load requirements on the roof, to cut chases for the electrical and plumbing. So if a jurisdiction adopts this, then the builder has to include that. They have to post a certificate, a solar-ready zone that it has already to affect the roof load. There's a pathway for the electrical and mechanical. There's room in the service, the electrical service, to accommodate that. So that's one of the amendments that we have to watch and we're considering. Now, the last one, again, alternative paths, we're talking about mandatory requirements. The alternative path, some call it above code. It isn't necessarily above code. The Chapter 5 of the Health and Safety Code, 388.003I, it says that a national, state, or locally accredited program determined to be in compliance with energy efficient requirements by the laboratory. That's Energy Systems Laboratory, the AEM. Then the building official can consider that to be in compliance. The only one that's specifically mentioned in the Health and Safety Code is the Energy Star program. It meets the equivalency of the energy code. So especially if jurisdictions in those 18 counties that are non-attainment for air quality, or the 110 effective counties, they cannot adopt the energy code with amendments that would make it any less stringent than what the state has adopted, unless they have verification that's been validated by Energy Systems Laboratory. Now, Energy Star 3.0 is equivalent or better than the 09 Energy Code. 3.1 is equivalent or better than 12 or 15. And so after September 1st, since Energy Star 3.1 is out, then that will be accepted for at least a year past the date that the Energy Code goes into effect. So Energy Code goes into effect September 1st. Say January 2017, Energy Star version 3.2 comes out. Jurisdiction can still accept construction documents using Energy Star 3.1 until September 1st of 17. I got so used to blasting through, I went pretty quick. Let me review. Again, all these compliance paths have to meet the mandatory requirements. Every one of them starts out with that. So again, it's the certificate, air leakage, maximum U factor and solar heat gain requirements, controls, duct sealing and testing, not using any cavities as ducts, mechanical piping and insulation. If they have hot water recirculation, there's requirements, mechanical ventilation, the sizing and efficiency using manual J and manual S. If they have snow and ice melt, if they have a pool or spa, if they have gas lighting, and then also the lighting equipment. All those are the mandatory requirements. So then the performance path, we've got 3 alternatives for the building thermal envelope. R values, the U factor, or the UA alternative, which gives you the most flexibility. It considers everything in the building thermal envelope. It also has insulation requirements, fenestration, insulation of ducts, the duct text, the duct leakage test, and the hot water piping insulation. If we choose the performance path, has to meet all the mandatory requirements, and then it's a comparison of the home built according to the basic requirements, and then the home with all the trade-offs that we want to use. If it'll use the same or less energy than that restricted home, then it passes. Then the Energy Star rating, Energy Rating Index. This also uses software. It has to meet the 2015 requirements for hot water. It has to meet the 2009 requirements for the building thermal envelope solar heat requirements. And then it uses this graduated score 0 to 100. And 100 means that it met the 2006 prescriptive requirements. And the code says it needs to be 48% better than that. The state of Texas has relaxed that so that in September it needs to be only 35% better. So it changes every 3 years. And then the alternative compliance, like Energy Star or other programs that have been validated by Energy Systems Laboratory. Remember to check local amendments because those could be much more restrictive. They might include the solar energy ready on the residential homes. And again, if they have adopted the energy code with no amendments, then that is the most that can be enforced. every law needs enabling legislation. If they don't have amendments to it, or it's not in a special overlay district with requirements, and that's the most. But it's incumbent on the builder and his representative to check on what the requirements are. There's a lot of training resources. If you put your name and mailing address on that card, we'll send you your code book. We ordered a pallet of them. So we've got, I think, 1,500, something like that. So we'll get you one. Apologize. I think they shipped today. So we'll get that out to you. Remember, it's basically 2 code books in one. First half is commercial, the back half is residential. Also on your card, if you'll write down any questions that you might have, you'll have Ask the Trainer webinars twice a month. Those will be live and free. In fact, you see here, this is on the, is this on one of the back pages? There's the schedule. Just remember it's at noon every other Wednesday, and you'll be able to connect in these ways. And you can email questions that you have so that they'll be addressed at these times as well. So that this is a continuous support for you as you seek to apply the code requirements. Also,
David, sorry, if you go back 2 slides there, the online training after August.
Oh yeah, after August, each of these programs will be recorded. I'm sure it won't be me, it'll be a good trainer. But you'll be able to log on and watch those, and that'll probably be for years, because you just took down the previous ones, right? So those will be available. If you go to the SECO website and explore it, there's a lot of things that are available there. It will help you whether it's commercial or residential. The Department of Energy has a great website for the energy codes. SPEAR has a good program. There's cards on each of the desks showing the assistance that they have. They, in 2013, started this ambassador process. It's building officials, it's HERS raters, it's inspectors, contractors that are considered experts in the energy codes. So if you have questions, or if you have difficulty in trying to get a project run through a jurisdiction, I became an ambassador in 2013. That's the little Waco DS right there. And most of them were building officials. At that time, there were only 7 certified energy code inspectors in the state. And 2 of us were those, and we love that number. It's expanding into Oklahoma. And starting next Thursday and Friday, they've got a third group coming on as well. So if you go on the SPEAR website, you can find the name and email and phone number to any of those ambassadors. And you can find one that's near your area. Another thing to remember if you're dealing with residential home builders is the $2,000 tax credit for building new homes that are energy efficient. At the end of last year, Congress renewed that. It expired in 2014. That's tax code section 45L. And it renewed it retroactively. So that was for any homes built last year and any homes that will be built in 2016. So that's another way to soothe the builders who feel like it's too expensive.
David, as he mentioned, these cards on your table, these are from SPEAR. And on the opposite side, it's visit their website there. Access our code adoption toolkit and resources for municipalities, schedule free trainings. So this is again another support and service to you. You can access information on SPEAR's website. Probably get to all of these through SECO's website as well. You'll get recommendations there. And today's workshop and all this is a support for you as building professionals in Texas to help you with compliance. It's really what it's all about. And in order to be compliant, you have to understand what the rules are and the laws. And so these binders, once again, are yours. And let me just make note that if you're taking notes, that the what's new in 2015 section of your binders, start on page 7 and go through page 13. That's the summary of all that's new, page 7 through page 13. And then the mandatory requirements start on page 13 in your binders and take you all the way through about page 36. So 15 to 36 mandatory, and then after that it's all prescriptive. So it's broken down into those 3 categories: what's new, mandatory, and prescriptive in your binders. And this is a place when you get your code books, again, it may be something you look at, take notes. This may be a smaller thing to keep with you than the code book, or both of them. But that was the purpose of today, was to just information, give you these binders, let you know summaries of what's new, mandatory to prescriptive, how it all works together. And then also letting you be aware of the continuing resources available to you through SECO, through Apple Energy Group, through SPEAR. We're here to support with information, webinars, trainings, whatever it may be, to help you along this path of compliance. So let's do a bit of, because we're early, Q&A for the last section that David went through, a prescriptive path. Anybody have any comments or any questions you want to ask? We have plenty of time here, so, or any other section. Yes, please.
I went first last time. Just a quick question. Sometimes we get disconnects between, for instance, if we're doing lead, like consulting with architects who's doing that, we'll get pushback or have conflicts. It should be taken care of in the design phase where, Energy Star's requirement, a prerequisite. Okay, people assume that if you've got your lead points and whatever, you're automatically going to meet requirements of Energy Star, which is not necessarily the case. Is there any disconnect that you're aware of between, say, Energy Star 3.1 and new mandatory requirements of code? Meaning that if somebody says, well, I'm going to get Energy Star, I'm not this thing, I don't worry about that in terms of envelope requirements, just anything that I know you can get into this. Anything that jumps out at you, disconnect, say, Energy Star.
I think by the time it gets to jurisdiction, it's been worked out. They might question some of that. I think it's educating the customer. The difference between the Energy Star. Yeah, that can be hard. And maybe this, this one help. Really, Energy Star is the only one that's named by code,
right,
as being the equivalence. The others have to be validated by energy systems. And it depends on which program is presented to whatever the building official has agreed. It's not in a payment area or going to be affected counties. The building official accepts the program as being equivalency. It's got to be the parameters of what was presented. Does that make sense?
It does. It does.
So while the lead may change, the energy code may change, and the energy code itself, Energy Star.
Yeah, I can't think of any off the top of my head. For instance, there are Energy Star requirements for do those. Say you took a performance path with new code, is there any conflict? Say you do the overall way you do it. So whatever, you can apply that way, that could even conflict prescriptive requirements. Something to watch out. Anything that
There's a certain method that has to be used.
right, exactly. So, but there's mandatory requirements for us to say, plus you could do Energy Star as well.
Because you have to define the path that you're going to use to achieve compliance. it's more clear with the commercial, you know, we have actually, and once you go down that path, you can go to it. So whether it's LEED or Energy Star, ERI, or performance, once that path has been selected, you can see the path. Some of them allow trade-offs that the others do. And that's the key thing.
Energy Star.
That's my whole point.
So if Energy Star doesn't allow it, you can't use a program that does the traffic patch. Did that answer your question?
I think so. Yeah, I mean, it's more of a cycle.
You know, for me, I tell people I have two brain cells and one of them tries to program. So I try to make it just as specific as I can to stick to them. You know, here's Energy Star, here's, you know, choose a path, stick with it, and you can't jump over the one. Each has, you know, its particular requirements. We have another question over here.
Things about attic spaces, so if you have a shed roof and it all has to be R38 zone 2 insulated, and if it's not, only 500 square feet is allowed to be less, I'm just trying to.
It's only 500 square feet or 20%.
Okay.
Whichever is less.
Okay. So
That's
once
the
you
only
get
amount
down-
that's allowed below that.
Okay, so you can go down, but there's that limit.
You can only drop down one step. So from R38, it can drop to R30. But you can
Got it. And then on slide 42, where you have the rim joist, so the ridge board installation would be like just outside of that.
That would be on the outside, but we would still need some like fiberglass insulation on the inside of the cabinet.
Okay.
Because if that's not addressed, then all you got is, you know, 2x6. That's your only thing that's left. So you need rigid insulation, you need your air barrier, you need some insulation.
Okay. All right.
This
I
one.
have a question, you mentioned chipboard. Not use that term, I guess that's.
Sheetrock or drywall.
Depends on your profession.
Well, actually, sheetrock and drywall are trade names. Gypsum board is what it's called. The code tries to be very neutral. Teaching these classes, we try to be, you know, building officials, inspectors, they all have to be neutral and not, you know, show a bias to one product over another. You know, it's like Kleenex and tissue, or Xerox and photocopy. So I just call it gypboard because that's what it is. Yeah. But sheetrock and drywall are actually trade names, but we're talking about the same. I know I've seen some things that actually compare stucco to gypsum. No, chipboard is this stuff on the other side of the paint. So maybe always question, but do the amendments alter the requirements of the manual? Are they only restricted? It depends on the jurisdiction. They can amend any section of the code because of their particular requirements. I know, like with the plumbing code, you know, they might specify a copper line, or exclude it because of various things, you know, dissimilar metals and that. And then that could cause another change. So that's the danger of jurisdictions with amendments, is they ripple out. So they have to be well thought of. Just like CEQA, they have to have stakeholder meetings so that professionals who use the code every day, they can express how it's going to affect any part of the code. As long as it's usually more restrictive. By the time it gets down to the local municipal level, you can't really relax and affect the code itself. It gives the building official the judgment to say if he deems something that's code compliant. Even if someone appeals, you know, to the standards commission or some body, you know, can overrule it. building official, they have to be able to prove that either that particular code doesn't apply in the situation, or the building official is being too strict, or what I have would meet the requirements of it. So we can't waive the requirements, but they can make it more strict by amendment. The whole purpose of that with the energy code, this is what I tell the customers, especially the remodelers and that, is they look at all the energy savings and emission controls that they've got out of vehicles in the last 2 decades, better miles per gallon, lower emissions. So we've got all we can out of internal combustion engines. Now how can we get similar savings and efficiency out of the built environment? Because if we use less energy, then we're less dependent on other sources or other countries. But even in our own area, the coal burning power plant doesn't have to pollute as much. It goes back to the air quality issue, so it's all interconnected. Yes, sir.
So I just wanted to see if there was any kind of update on, I see here it's got supply and return ducts, but what about exhaust ducts as far as installation goes?
As far as the air movement or the efficiency of, there are fan efficiencies.
Well, like, because, yeah, the R value for the exhaust duct, right now we're doing in San Antonio, we're not doing any R value, but I've heard of north, like in Austin, they're actually using like R for it, for the exhaust.
Okay, for
Raising in the fire.
Okay. Okay. Yeah, I was thinking of our value on the fan. So,
No.
because the commercial actually requires the construction of the fan itself. So you're talking about the exhaust ducts?
Yeah.
Yeah, to eliminate condensation, not bringing air in as far as your changes. No, that's something that the local jurisdictions would make based on their particular climate requirements. Mr. Lackey?
Very good. David, one last question. You talked lastly about there's a tax.
Yes. Tax credit.
Credit. $2,000. Is there a score that has to be achieved, or how do you prove to Sam?
The particulars are in that 45L. It goes back to previous editions of the code and what percentage gets better than those. Basically, anything built to the 2012 or 2015, especially with high efficiency HVAC. It's tax credit 2.0.
So not home buyers.
No, it's not the buyers, it's for the home builders.
David, do you recall a area that they could go to on the internet to locate that information?
Yes, it's IRS.
Yeah, there you go.
Well, there's a great website I built, and it's Desire, not with an E. It's DSIRE.org. It's maintained by, are you all familiar with that? That's usually where, that's all the incentives. We put ours on there. The utilities use that. It's a United States government supported website, I think, by North Carolina. It's funded by the government. DSIRE.
Another good source is SEIA. The 09 and the 12 code, they had some great binders, workbooks, spiral bound. one for the builder and one for the building official. You know, I like photos, like I said, if I can make it as simple as possible. Photos of what does work and what doesn't work. I haven't seen them yet for, not wrong. This is one that they provided. I haven't seen them for the 2015 code yet. Success with the 2012 code, and it breaks it down by each component. Foundation, framing, HVAC, electrical, plumbing, air sealing, insulation, and the index. And each of them, each section has a checklist on what's to be inspected, and then it ends up with the pictures. You know, examples of what's good, what's not good, what needs to be corrected. And this was produced by Southeast Energy Efficiency Alliance. So I use these a lot out in the field with builders. Because when you can show them a picture, then it's really easy to understand. Again, I haven't seen it for the 15 yet, the 09s and the 12s there. And like we said before, most of the changes in the 2015 code occurred with the 2012 code, especially changing from just an inspection to testing, air sealing requirements, and so this is a good resource we can use. I always try to have as many tools as I can because every situation is different.
What compliance path would you do if you were doing a net zero home? Would it be the ERI? Would that be the best one?
I'm gonna say yes.
Yeah.
You gotta have a score. So you gotta have a HERS rating or
Right.
ERI, which is essential.
Right. Okay.
Give me a shot when you get it built. I want to look at it too.
The only weird thing is to come forward, right, where it's
Right.
something was that you could, you have to.
Yeah, right.
You have to have something. So, okay.
You can't count wind and geothermal.
And then when is the best time for that to begin? Like, is it in the concept phase? Okay.
So the ground line.
Okay, all right. Siting. Got it. Okay.
Yeah, that's where the variations in your climate zones are important. And you got to look at each. I mean, it can change within a lot. So,
Fair Oaks Ranch, a city that transitions to climate systems. You have a house at different schools that are right across the street. So,
doesn't that also separate the warm noise?
yes,
And,
yes, you got it all.
so you could build a house, and on the other side, mother-in-law's house will be different.
The city of Fair Oaks Ranch decided to just go to the higher, so their higher city. Although most of it is
There's that jurisdiction checking.
there's that jurisdiction.
David, how much time do you spend on slide 105, the software? We talk a lot about that. Page 53 in your participants guide, all the different softwares that are available, slide 105. And we spent time talking about this in our preparation. Yeah,
This one here.
this one here.
This gentleman here is a HERS rater, so he can use REM rating. I've, as a plans examiner and building official, accepted a lot of, probably equal number of REM rate and res check. But if you're not a HERS rater, you can't use REM rate. The ones on the left are free. IC3 we mentioned, will be ready for the energy rating index by September. Again, this,
David, I think that's the key also, is the energy rating index. Res check, be off, will not give you rating. Rem rate, energy gauge bill, I keep hearing about IC3. It's, right now, ResNet and I think Energy Star will only accept rem rate, energy gauge. So we get it.
Would you pay for those?
$350.
So and again, the IC3 will be Texas driven, of course, for the most part. That's where it's coming from, and it'll be free. As you stated, it's the ERI ready. Should be ready by the time everything is logged.
Now, for like production builders that don't use the ERI, if they're just one prescriptive UA alternative, the Res Check is great. What's nice about the Res Check is it has almost endless amount of drop-down menus to be able to select what assemblies or what components are being used. It shows you how that affects your final score. It even shows either red or green, if it passes or it doesn't. If it does pass, it shows by what percentage it's more efficient based on. I think today it's almost essential for a builder to familiarize himself with one of these programs and use it so that.
I'm not an expert, but I was told Fiat did take.
I think we got. I think it does too. It's out to.
I think Res Check's not very good.
I've got notes on those. I'll bring these.
I had a substitution request for the spray insulation, and they gave me the energy compliance, the EECC report. And is that to verify the spec? Is that the third-party tester that tests? Like, what? How do I process that?
Yeah, the evaluation service report means that it's tested per the manufacturer's installation instructions as to whether or not it meets the specific.
And they were at the 2012, and they didn't have the 2015 branded report. Should they?
Yeah, in order to be used under the 15, it has to meet
Right. Okay.
those changes. And you know, as we go through the code, you see so many things that say they have to be listed and labeled or approved. Approved means that the building official will accept it. And that's where, you know, the building official should say that's good for the 12. Listed and labeled is that the manufacturer, like the tight-fitting doors for a fireplace, he submits his whole assembly and installation instructions to an approved testing agency. And then they put it together based on the manufacturer's instructions. And then they test it according to ASTM or whatever the code requirement for that test is. And then it gives them, you know, a pass or fail, you know, showing that it meets those requirements. That's why on almost any component, the code yields to the manufacturer installation instructions. Otherwise, it wouldn't be listed and labeled. It has to be put together that specific way. And if they don't have a specific listing, or if it's a new product, and the code tries to leave room for innovation and new products, then the building official can accept an evaluation report from an approved agency, meaning he respects it. He's seen the work they've done. Even the testing agencies, they have to be tested. They have to meet certain requirements. I went through that with sill plate anchor bolts. You know, anchor bolts to mud sill anchors, and now, you know, changing out every kind of mud sill anchor. You know, how does the space, you know, change? So with an evaluation service report, they analyze it, they test it for uplift, you know, the code requirements, and then they deem that it meets the requirement. You know, mud sill anchor.
So we're on 2015, and that report only goes to 2012, and I need to turn around and say, I need the 2015, or the building official has to sign off.
You have to look at it a little closer. If the 2012 says it has to meet this, for example, this assembly has to meet this leakage requirement based on this test. The test might be the same for 12 and 15. The leakage requirement might be the same. So in that case, it could be acceptable. That's why the code allows the building official to, for him to say, you know what, the addition of the code is different, but this specific requirement hasn't changed. You know, if it met the test before, and then the code requirements change, it's still meets the.
And then I just had that last question about the spray foam insulation, ignition barrier, and like, are you painting something on, or is it inherent to the spray foam insulation if it's less than?
None of the spray foam meets the requirement unless an approved additive has been included and it's been applied properly, or coating has been applied. Without either of those, then you need the emission barrier for just mechanical in that enclosed space or thermal barrier. Which basically, if you've got the decking, aside from just the path leading to the mechanical equipment, you have other, you know, decking.
It's just a crawl space to circle it.
Do they have their Christmas lights?
No.
Do they have mechanical?
No, just pipes.
No source of information.
There might be some gas pipes down there, but no, not.
Check with your AHJ, right?
Right. Is the duct seal test required once or twice? Because I heard you say rough in and at the end, or you do both.
You have it, on the ducts, you have the option, either at rough or.
If you did final, would you do it at rough in? Yeah.
If they charge every time they do it, but, absolutely.
The difference in shape, that changes gigantic for these guys. Your mechanical contractors, getting them or total or free total and roughing. It's going to be hard for them. It's not good.
You run your duct glass.
I would do it.
Because I do total leakage.
Yeah, I think you've got to run the duct blaster at the same time you do. If you've got equalizer, you can also.
There's two tests. One doesn't have the R, the other one does.
So, most of the builders I've dealt with, they save everything for the last minute.
Smart builder.
Yeah.
Right.
And they do it blower.
That changes a bit. The new threshold.
I see advantages in both. You know, when you catch it at rough, you know, you have easy access, you know, you can repair it, you can replace it. And again, a lot can happen between that time and final as well. And then at final, I've had people move into a house and there's no energy certificate. You know, they don't want to let me in, and I'm, you know, a builder, it's like, you don't even have a CFO. So that's great. I like everything planned out.
One quick question on that, and actually probably not this, but in the chapter on existing buildings, you do a lot more. Does it cover when, for instance, that does requirement? What triggers that? Full replacement? Or is that just at the municipality level?
A lot of that is up to the municipality. You know, there's an exception on the existing as far as what the building condition space, but actually got the leakage. If you're expanding the condition space, you know, then you can't do requirements after that. It's smart. You know, if you're adding new ducting to existing, or extending the mechanical. But
Smart.
definitely smart, but that's, not everyone can be accused of that.
Just bring your attention once again to the back of your participants guide for the resources. There will be the webinars starting March 2nd. It'll be basically every 2 weeks on Wednesdays, 12 noon. Try to schedule it during most lunch breaks. So it's a Q&A time. It'll be live. We'll have somebody be on, David or Mike or John or another code expert answering questions. So if you want to make note of that and you put it in your phone or whatever, just you can jump on. The coordinates are on there. If you have any problems, feel free to email us.
Why?
2 phone numbers, platform provides. You can go either way. Get you to the same place. I guess if you can't connect with one for some reason, there are 2. So both of those will connect you to. If you use the telephone, then you just do the meeting ID, typical prompts, +#. Or if you're on a PC, Mac, or a smartphone, you can do the URL that's there and take you right into it. Again, if you have any questions, email us at training@appleenergygroup.com. Then the schedule's on the right. And don't forget the next page, the ambassador program, Sphere's website, Seco's website. Hopefully through those you can get as much info as you need, or at least get directed to the right place to get that information.
Are these going to be specifically thoughtful, where you more down into the aspect?
Good question. Yes, we'll try to do that once we gather all the questions that people leave on these cards. We'll filter through those and try to find the common questions that are being asked, so we address that on each webinar. We'll probably try to push out some email announcements, reminders of the webinar, and the topic on it as well. Thank you for the question. Any more questions? We're about 10 minutes to finish. If you would as well, if you haven't already, just one last reminder, the sign-in sheet of your requested CEUs. The cards are there for you to take with you, these Sphere color cards. You can take one of those if you like, as well as the evaluation form. If you haven't done that, if you'll leave those, fill those out, leave those on the table, we'll collect those and be gathering them back to our corporate office. If we don't have any other questions, we appreciate you coming here today. Thank you for your time. Again, we will make sure you give us your shipping address so we can get those code books out to you ASAP. And so glad you were here once again. Thanks to Burgess for the hospitality and food in the room. Very comfortable. So this afternoon we're having the commercial version of this workshop. Mr. Mike Lackey will be delivering that. We're back again tomorrow morning here with David Swatek for residential. And then tomorrow afternoon, the commercial class, Mike Lackey will be doing once again at a different location tomorrow afternoon. Full already at about 30 people. So we, again, thank you very much.